The universe has long captured humanity's attention with its countless fascinating structures. Among the strangest of these are stars, and especially neutron stars, the subject of today's video, which push both our understanding of space and the limits of our imagination. To many people, neutron stars are simply small objects with enormous mass, but when you dive into the details, you begin to realize just how strange, fascinating, and even beautiful these objects truly are. So if you're ready, let's take a closer look to better understand both stars and neutron stars. Neutron stars are born at the very edges of the universe, in realms where even physics begins to struggle, yet they are not the result of a birth but of a death. They are, in a sense, the eerie legacy left behind by a dying star's final scream. Everything begins when a massive star, at least 8 to 10 times more massive than our Sun, reaches the end of its life. Once it exhausts its fuel, it can no longer resist its own gravity. The core, having held itself up for millions of years, suddenly collapses inward. Protons and electrons are crushed together, merging into neutrons, and the star violently ejects its outer layers in a tremendous explosion known as a supernova. What remains is an object roughly the size of a small city, yet many times more massive than the Sun itself. This remnant is what we call a neutron star. The mass of a neutron star is easy to describe in words, but nearly impossible to truly comprehend. Across all forms of media, social media, television, documentaries, you often hear the same statement. A single teaspoon of neutron star material would weigh as much as Mount Everest on Earth. To many people, this sounds exaggerated or unbelievable, but it is absolutely true. The real question is, when we say this, do we truly understand what that kind of weight means? Honestly, probably not. If we did, far more people would be deeply curious about neutron stars and eager to study them. Instead, many choose to focus on celebrity news, politics, or mythology. But setting that aside, the reason neutron stars are so incredibly dense is that matter no longer exists in the form of atoms as we know them. Protons and electrons are crushed so intensely that they almost completely transform into neutrons. Atoms collapse so thoroughly that no empty space remains between particles, to the point where not even the tiniest known structure could pass through. Matter no longer behaves in its familiar form, but instead like an ultra-dense neutron soup under unimaginable pressure. Gravity on a neutron star is so extreme that jumping from its surface would be impossible, but let's imagine somehow that you could. Before you ever hit the ground, you would be stretched and torn apart like spaghetti. This phenomenon is known as spaghettification, a term that may sound familiar as it also occurs near black holes, and remarkably, neutron stars can cause it too. Now let me ask you a question. Do you think the only thing that makes neutron stars special and incredible is their immense mass? Let me answer that right away. Of course not. Just as fascinating as their mass are their rotation speeds and magnetic fields. Some neutron stars rotate so incredibly fast that they can spin hundreds of times per second. These stars are known as pulsars. As they rotate, they emit radio waves from their magnetic poles, and these waves reach Earth like the sweeping beam of a lighthouse. What's even more astonishing is how regular these signals are. Some pulsars are considered more precise than atomic clocks. Their magnetic fields, on the other hand, are trillions of times stronger than Earth's magnetic field. These fields can bend space, tear matter apart, and even guide light itself. In other words, these objects are so extraordinary that they are capable of influencing light. This is exactly why many people insist that the human mind simply cannot fully comprehend certain things, and honestly, they're right. If we had discovered these phenomena without any scientific background, or even witnessed them with our own eyes, we would never believe them and would likely attribute them to some divine force. I know many people will accuse me of being anti-religious here, but let me be clear. I do believe in God, and I believe that a higher power played a role in creating order in the universe. However, if we as humans simply say God created it and step aside, if we stop questioning, researching, and progressing, we are a species destined to disappear. In many religious texts I've read, the core message is not blind acceptance, but understanding the logic behind creation and the systems that were put in place. So instead of accusing people who study space, the universe, or science of godlessness, I encourage you to do what God truly wants: research, question, and learn. Now, returning to our topic, magnetars, the most magnetic objects in the universe, are actually a type of neutron star. A single eruption from a magnetar can release enough energy to affect satellites across half a galaxy. As you already know, even Earth is strongly influenced by the Sun's magnetic activity and solar flares. Some of these eruptions can disrupt radios, GPS systems, and technological devices on our planet. Now imagine what would happen if a magnetar-like object were anywhere near us. So, do you think our Sun could one day turn into a neutron star? I can almost hear many people saying yes, but that is not possible. The Sun simply does not have enough mass to become a neutron star. When the Sun reaches the end of its life, it will expand into a red giant, then shed its outer layers to form a planetary nebula, leaving behind a white dwarf. Our Sun will never undergo a supernova explosion as it lacks the necessary mass. Therefore, the birth of a neutron star from the Sun is physically and scientifically impossible. But let's ask a hypothetical question. What if the Sun did have enough mass to become a neutron star? What would happen to our solar system? If, by some magical touch, the Sun suddenly transformed into a neutron star, the first major change would involve its size, not its mass. Neutron stars are incredibly dense but extremely small in volume, yet their mass is often similar to that of the Sun. If the mass remained the same, the planet's orbits would theoretically remain largely unchanged. Earth would still orbit the Sun. However, there is a crucial detail that is often overlooked: light. Neutron stars emit almost no visible light. Within minutes, Earth would be plunged into complete darkness. Photosynthesis would stop, plants would begin to die, and without human intervention, most plant life would eventually disappear. Temperatures would rapidly drop, and Earth would begin turning into a frozen world. Much of the oceans would freeze over. Under normal circumstances, most, if not all, life on the planet would perish. However, the biggest determining factor here would be human technology. If humanity's technology were more advanced than we currently imagine, humans might survive underground or through artificial means. Animals could potentially be preserved before extinction, and thanks to advanced agricultural technology, artificial photosynthesis might allow plant life to continue. In short, while much of Earth's life would be lost, humanity might retain enough capability to continue its species. Of course, not all life would survive. Ocean ecosystems would largely collapse, and insects would suffer massive losses. Yet many organisms critical to sustaining civilization could potentially be preserved. Unfortunately, in such a scenario, survival would likely favor the wealthy. Ordinary people would either perish or be forced to live in harsh underground conditions. But let's return to the main issue. Once the Sun ceased to behave as a normal star, solar winds and balanced energy output would disappear, causing Earth's atmosphere to slowly escape into space. And this isn't even the biggest problem. The greatest danger would be the supernova explosion required for the Sun to become a neutron star in the first place. Such an explosion would release an unimaginable amount of energy. The inner planets would be instantly vaporized, and the outer planets' orbits would be disrupted, leaving behind a chaotic field of debris. In such an event, Earth surviving would be unlikely, keeping its atoms intact would be nearly impossible. Let's not confuse this with the earlier hypothetical scenario, where the Sun magically transformed into a neutron star without exploding. I mentioned this specifically so no one comments, if Earth would be destroyed in the explosion, why even consider this scenario? Now here's another truly astonishing fact. In recent years, scientists have discovered planets orbiting neutron stars, and they've likely existed for a very long time. In fact, the first exoplanets ever discovered were found orbiting a neutron star. These planets were detected through tiny irregularities in a pulsar's extremely regular radio signals as they orbited around it. This is one of the greatest ironies in astronomical history. Planets were discovered around a star that is considered dead. I know many of you are wondering how these planets survived the supernova explosion, or how they exist at all. According to scientists, many of these planets may have formed after the supernova. The remaining gas and dust eventually came together to form second-generation planets, cosmic orphans born after a star's death. Others believe some planets may have survived because they were far enough away, though their orbits would have been altered. These planets are likely bombarded by extreme radiation, constantly struck by high-energy particles, and completely hostile to life as we know it, yet they exist. The universe is such a strange place that nearly everything humanity once said was impossible turns out to be possible. We're left only trying to explain how. Recent studies even suggest that some planets in neutron star systems may have far more complex structures than we once imagined. Some may be extremely rich in metals, with cores composed almost entirely of heavy elements. After all, supernovae are the primary source of heavy elements like gold and platinum in the universe. Theoretically, a planet orbiting a neutron star could contain far more gold than Earth, though reaching it would require unimaginably advanced technology, likely hundreds or even thousands of years beyond our current capabilities. Neutron stars remind scientists and humanity as a whole that the universe is not made up solely of beautiful nebulae and calm planets. It also contains structures that are deadly, chaotic, merciless, and that push the limits of physics itself. That's why studying the universe requires extreme precision, and why human space missions must be planned with the utmost care, because even the smallest miscalculation can be fatal. Yet, as you've seen, even in the most chaotic environments, planets and structures can still exist. Scientists have learned a great deal from this, and now search for life not only on calm, Earth-like worlds, but also in environments once considered completely hostile. I hope I've been able to inform you well about neutron stars. If you have any questions or topics you're curious about, please don't hesitate to leave a comment. Every question, idea, and opinion means a great deal to me. That's all from me for today. I'm heading back to my research to prepare the next video. Until then, don't forget to subscribe to the channel, like the video, and recommend it to your friends. See you in the next documentary. Take care and goodbye.